What's up, guys? In this video, what I want to do is get you ready for equations and inequalities in Algebra 2. Usually you'll find this content at the beginning of the course. So what we're going to do is go through 4 different questions as well as multiple examples. So therefore, when you start this chapter, you are going to be ready and prepared with the knowledge that you need to know to be successful. All right, so let's go ahead and kind of get started on the first one, which is just going to be solving some basic equations. So remember, when you're solving linear equations, the main idea here is we want to isolate this variable, right? So we want to isolate the variable by using our inverse operations. And the first thing we're going to want to do is understand what's being applied to this variable. So in this case, we're multiplying by 5, and the variable is also being added by 8. So we're going to undo addition by 8 by subtracting the 8 on both sides. That's now going to give us a 5x is going to equal, now this is a negative 27 minus an 8, right? So if you owe me $27 and you subtract or you borrow another $8, you now owe me $35, right? So it's a negative 35. And now I will undo multiplication by 5 by dividing by 5, and I get x is going to equal a negative 7. Now in the next example, again, a lot of students will see fractions. They're like, I don't like fractions. But remember, what's really happening with this fraction? It's just being multiplied by the x, right? So like in the last example, we're going to do the exact same thing. First thing we're going to want to do is go ahead and undo addition and subtraction first. So I'm just going to add the 1 to both sides. So if I have a negative 2/3, x is going to now equal to 4. Now, in this case, we undid multiplying by 5 by dividing by 5, right? And you can do the exact same thing. To undo multiplying by negative 2/3, you could divide by negative 2/3. But hopefully you recognize here that dividing by a fraction is the same thing as multiplying by the reciprocal. So I'm going to multiply by the reciprocal. Now, you could do the positive version, but again, I want to solve for x, right? I don't want to solve for negative x. So therefore, I'm going to multiply by negative, because a negative times a negative is a positive. So therefore, I have a negative 3/2, and then this will be times 1. So therefore, x is going to equal, now in this case, like, what do you multiply? So you can see what I did is I put a 1 under the 4. So therefore, I can write the integer as a fraction. So now I can just multiply straight across, right? So 4 times a negative 3 is going to be a negative 12, and 1 times 2 is going to be a 2. And again, just remember, from like, you're going to want to make sure, especially going into your class, that you always simplify your result. So 2 divides into a negative 12. That is going to be a negative 6 times. All right. Now in this example, we're going to have a variable on both sides. So just remember, when you have like a variable on both sides, the first thing you want to do is get the variables to the same side. Okay. So it doesn't really matter what side you do. I typically like to go ahead and solve for the variable on the left-hand side, unless it's going to make it negative. Therefore, sometimes it's a little bit more extra steps. So therefore, it's going to be a 5a plus 8 equals a negative 6. Then I can subtract an 8 here on both sides, and I get a 5a equals a negative 6 minus 8, which is going to be a negative 14. Divide by 5, and now I get a is going to equal, now 5 does not divide into a negative 14, so therefore I'm just going to leave this in fractional form of a negative 14 over 5. One thing to remember too, like, it doesn't matter if this is negative 14 over 5, or if it's a 14 over a negative 5, or if it's a negative 14 over 5. Like, those are all the exact same thing. So I didn't want to be confusing over here. Like, I put the negative up top. You could easily put it down below, but again, it doesn't matter. Either way, you're going to get a negative 6. Just don't put it in the top and the bottom. Then you'd have a positive number, right? All right, so the next one is going to be solving and graphing inequalities. In terms of like the solving, it's basically the exact same thing. We're just going to be using our inverse operations, but then we're going to graph them using a number line. So in this case, you can see I have an x being divided by 2. So I want to undo dividing by 2. So to undo dividing by 2, I'm just going to multiply by 2. Right? So when you multiply by 2, now I get x is going to be a greater than 6. So how are we going to graph this? Well, if you think about like the x-axis, right? And you think about like the Cartesian coordinate point, we have like the x-axis and the y-axis, right? And so let's just say we have an x-axis, just the x-axis, in which we could also call like a number line, right? So you have like 0, and let's just kind of go by, I don't know, let's go like positive 6, negative 6, and now let's put a 10 here. I'm not going to do all of them. In this case, I just want you to kind of see how we can do this here. So this is going to say, I want to find all the solutions, or I want to graph the solutions that match up to x is greater than 6. So again, think about like what numbers would satisfy that, like 7, 8, 10, 11, right? Not 0, not negative 6. So we're going to say, all right, so we're going to say, we're going to put an open circle here. And again, the reason why this is an open circle, because it says x is greater than 6. 6 is not greater than 6, right? 6 is equal to 6. So therefore, it's going to be an open circle. And then we're just going to kind of shade going to the right-hand side, because all the values to the right are going to be greater than 6. Now in this example, remember what we basically want to do is, again, use our inverse operation. So we're going to divide by negative 5. Now in this case, remember whenever you're multiplying or dividing by a negative number, you have to make sure you flip the sign. So this is going to be x is greater than or equal to a -3. Okay, now I typically like to do my number lines a little bit faster in this case, and I like to kind of take whatever my value is right here. I'll just say like that's going to be my center. So let's say here's -3. Now to the left, what should go to the left? Like let's say -4, right? And then to the right, what should be there? That'd be numbers larger. So it'd be like -2. So you don't have to do a full number line like I did in this top example. But again, like you should have values to the left and to the right and know which one's going to be less and which one's going to be greater. Now this is saying x is greater than or equal to -3. So we're going to start at -3, right? That's kind of like our boundary point, but it said x can be greater than, which is going to be to the right, or it could be equal to. So we're going to fill it in, and then we're going to go over to our right, over to the right, and that's going to represent all the values that are greater than or equal to a -3. Now, the next one we have is a compound inequality. And there's a couple different ways you can go ahead and do the compound inequality. You can do it exactly as it's written in here, or you can simply just rewrite it as a negative less than or equal to an x plus 1. And you could write it as an x plus 1 is less than 5. Okay, so the main important thing when I'm talking about the and is we're looking for the intersection of these two inequalities. Okay, so you can solve them separately, or what's really cool is you can also solve them at the exact same time. So if I have a -1, right, you owe me $2 and you borrow another $1, then you now owe me $3 is less than or equal to an x, which is less than a 5 minus 1 is going to be a positive 4. So in this case, we kind of have two values, and the x is going to be greater than or equal to a -4, but it's going to be less than a 4. And again, you could do it separately over here. It just kind of makes it a little bit more, I think doing it this way is a little bit more difficult, but it's not, but it definitely is something that is still kind of important, or just to be able to do it, you could do it separately and then find the intersection. But from here, the reason why I like it doing this way, actually, you know, I'll do it that way as well, just in case so you can see. So we get -3, 4, right? We could say like zeros in between. And it says x is greater than or equal to -3. Okay, so we fill that in, but it's less than 4. So it'd be an open circle. So it's going to be everything in between. Now, let's say I did it this way. Let's say I actually did them separately, right? So you'd have a -3 is less than or equal to x, and a x is less than 4. So how would this look out? Well, what you basically want to do is graph both of them together on the same line, and then find the intersection. So if I said like x is greater than -3, so we go like this, right? But again, that's going to be all values greater than -3. And then from 4, it'd be x is less than 4. So that's an open circle and be all over there, right? So again, we're only looking for the intersection, which is represented over here. So that's why we would write that as our solution, right? So this would be the or solution if you were to include both of them. Which we're not trying to include both. We're trying to find the intersection where they're both true. And you can see where they're both true is going to be represented right there. All right, let's go and take a look at the graphing the linear equation. So in graphing the linear equations, really the main thing that I want you to remember from like your graphing days is y equals mx plus b. Okay, and then also to understand like how do we graph. So this is what we call slope-intercept form, right? We have the b, which represents our y-intercept. And we have m, which represents the slope. Now, again, the slope is basically going to be the relationship between any 2 points on the graph. And that relationship, a lot of times we call like the rise over the run, or the change in the y over the change in the x. But really, the first thing we want to do is find like this y-intercept. Like, where does the graph cross the y-axis? Because all linear lines, I should rephrase that. All linear lines, except for, I guess, vertical lines, are going to have a y-intercept. So in this case, you can see my y-intercept is at -4. Now we can write this as a coordinate point, right? X is going to be equal to 0, and this represents my y value, which is a -4. So let's go ahead and plot that. And when I go ahead and plot that here, I'm just going to basically create my x and y axis. Remember the x-axis? We did that for like the number line. Well, now it's a vertical. Now we have a vertical axis, a vertical number line, which we'll call the y-axis. So we have 0, -4. So I'll go down 1, 2, 3, 4. Okay, played a nice little dot there. And then now we have my m equals 2/3. So how do we understand when my m is equal to 2/3? Well, basically what that says is between any 2 points, we're going to rise 2, and then you could say like your run is going to be 3. Basically, you're going to run is like you're moving left or right. Now, since this is a positive 2, we're going to go up 2. And since this is a positive 3, we're going to go to the right 3. If this was a -2, you'd go down 2. And if this was a -3, you'd go to the left left 3. So we can go up 2. So we go up 2 and then to the right 3. 1, 2, 3. Now the cool thing about writing or graphing a linear line is you only need 2 points, right? Because this relationship remains the same between any 2 points. It's also just important to remember that you can go to this relationship to the right, but you could also do it in the opposite direction, right? So if I go up 2 to the right 3, I could also go down 2 to the left 3. 1, 2, 3, because that's also going to maintain that same relationship. All right. So because again, like the main thing I want you to take away from that is remember, a negative divided by negative is still going to be a positive, right? So that is what that graph would look like. Now it's really important to remember that when you are graphing a line to always make sure you put it into slope-intercept form. Now, actually in this one, you don't have to do it. Well, you don't have to put this in slope-intercept form. You can actually solve this using the intercept method, but I'm going to put this in slope-intercept form. But I will show you how to find the intercept method here. So let's go ahead and put this in the slope-intercept form. And then because there's something I want to explain to you about this one. So to put it in slope-intercept form, just go ahead and subtract x on both sides. And you get y equals a negative x plus 2. Now, the reason why this problem is like kind of important is because a lot of times students will see nothing in front of the x and they say, oh, there's no slope. Well, no, there is a slope. The slope is going to be a negative 1. So when you have that minus x, remember that's going to be a negative 1 times x plus 2. So again, going with the same idea here, we're going to go to a positive 2. So I'll have my nice x and y axis. I'm going to go up to positive 2. That's my y-intercept. Make a nice little dot. Now, again, I have a negative x. Now, here's where it kind of gets interesting. So we have a negative 1. Well, if m equals a negative 1, like, what do, right? This was easy. This was 2 over 3. Rise, up, rise over run, 2 over 3, negative 2 over negative 3. Either way, whatever worked. But what do you do when it's just a number? Well, remember, you can always write the slope as you can always write a number as a fraction. So negative 1, or at least a rational number as a fraction. So negative 1, you can just rewrite that over 1. And remember, that's the same thing as a 1 over a negative 1, right? So it doesn't matter. Do you want to go down 1 to the right 1? Or do you want to go up 1 to the left 1? That is why that works. If you can go either to the right or to the left, you just need to make sure you adjust your rise accordingly based on the slope. So now I can go ahead and connect these 2 points, and that's what's going to look like. Now, the other thing I wanted to mention to you about this is we could also use the intercept method, or at least identify the x and the y intercepts. So remember the x-intercept, right? Wherever the graph crosses the x-axis, if you look at the y number line, y is going to equal to 0. So what is that value? So the x-intercept, y is equal to 0. So if you put a 0 in for y, it's going to be 0 plus x equals 2. Well, then the x-intercept is going to be x equals a 2. So therefore, that'd be the second tick right there. Now, the y-intercept, we already knew that was a 2 because that's listed right there. And you can see that's kind of represented in the graph as well, right? So just a nice little point, like you could also find the x and the y-intercepts and then connect them. That's what we call the intercept method. All right, in the next example, you could use the intercept method, but again, it works like for this because 2 and 4 evenly divide into 16. But again, I still really like that students have this understanding of being able to identify the y-intercept and the slope between those 2 points. So that's just the way I'm going to do it. You could also do the slope-intercept or use the intercept method if you want to. But if I want to solve for y, the first thing I'm going to do is subtract a 4x on both sides. So I get a 2y equals a negative 4x. What is that? Plus 16, right? And then you just go ahead and divide by 2, and I get y is equal to, so a negative 4x divided by 2, that's going to be a negative 2x. And then a 16 divided by 2 is going to be a positive 8. All right. So again, we have this kind of issue with a number for our slope. So m equals a negative 2. Well, again, we can rewrite that as a negative 2 over 1, which we can also write that as a 2 over negative 1. So just remember, all those are going to work, and they're kind of interchangeable with each other. Then what I want you to do is find the y-intercept, which in this case is going to be 8, right? So it's 0, 8. So we go 1, 2, 3, 4, 5, 6, 7, 8. All right, now in this case, we're just going to do it. I'm just going to do it real quickly. Like, I don't really want to go to the right. So I'm going to use the one where it's going to go, let's see, up to, actually, I want to go down. So to go down, then I'm going to use this one. So it'd be down 2 to the right 1. So down 2 to the right 1. And you can see here, it's a little bit steeper of a line. But again, you don't need to go to the left and to the right like I did for the first 2 examples. Just find 2 points and then connect them, and you are good to go. So I think it's really important to recognize, actually, you know what? Let's just find what the x-intercept is. Let's just have a little fun. I wasn't planning on doing this, but how would we find the x-intercept? Again, x-intercept is when y equals 0, right? So let's do 2 times 0 plus a 4x equals 16. So therefore, that's going to give us a 4x equals 16. Divide by 4, right? Solve the equation. X is going to equal a 4. So 1, 2, 3, 4. Looks like it was, it could definitely be comparable, right? That makes sense that works. So just another way to kind of verify that your graph as you drew it was correct, right? You don't want to have like the same positive slope or anything like that going on. All right, for question number 4 is just going to be following the order of operations. So, one of the big mistakes that students will make, throughout all of a math class is just like going back to remember the order of operations. So it's very important, not only when you're doing the math like on a piece of paper, but also when like sometimes you're typing into a calculator, if it doesn't understand the order of operations, just make sure you are doing things in the proper order. So therefore you can get the same answer as your teacher on your test or whatever it may be. So whenever you have a order of operations with multiple kind of multiple parentheses or grouping symbols, always do the innermost one first. Okay. So you can see in this case, you can see I have a 9 minus 2. So 9 minus 2 is going to be a 7. So therefore I have a 21 minus 7 divided by 2. All right. Now, again, remember the first part of PEMDAS or GEMDAS, whatever, is going to be doing those grouping symbols, those parentheses. So 21 minus 7 is going to be a 14. So therefore I have a 14 divided by 2. And now I can just do 14 divided by 2 is going to be a 7. Now, the one thing I want you to notice is, do you notice how I did like one thing at a time? Obviously, the more difficult the problem, sometimes you're going to have to do multiple steps. But I do also think it's really helpful for students to avoid making mistakes by just doing things one step at a time. All right, so in this one, again, we have a couple things going on here. So we have 12 minus a 15. So that's inside the parentheses. We got to do that first. So 12 minus 15 is going to be a negative 3. And now in addition to this negative 3, let's see. In addition to the negative 3, I'm dividing that by a 3 squared. Okay, now again, be careful. Now we have to actually make sure that we're actually writing out what's exactly happening. So in this case, remember PEMDAS. So we have PEM parentheses. Now we have exponents, right? So I have to be able to find my exponent. So 3 squared is going to be a 9. So this is a negative 3 divided by 9. Now, a lot of students will get stuck sometimes because they're like, hey, 9 does not evenly divide into negative 3. And you're right, it does not. So what I'd recommend doing is rewrite it as a fraction. Negative 3 divided by 9 is the same thing as a negative 3 divided by 9 written as with a fraction bar, right? And now you can say that, all right, 9 does not divide into negative 3, but I can reduce this answer, right? I can divide a 3 on the top and on the bottom. And when I do that, I get a negative 1 over a 3. So therefore, I can now say my final answer is going to be a negative 1/3. And again, that negative could be in the top, it could be in the bottom, or you could just go and write it out in front. Now in this example, what you can see here is we have our parentheses, right? So we're gonna have to work on that first. Now inside this parentheses, though, we have a multiplication and we have a subtraction. So let's see here. So if I already did parentheses, right? We have exponents. But again, we got to do the parentheses first. But let's just go through PEMDAS. Now we have multiplication and division, and then we have addition and subtraction. So the reason why I am writing that out there for you is because inside here, I have two operations inside the parentheses. I have multiplication and I have subtraction. Well, multiplication comes before subtraction. Now, again, before I go over this, just a quick review. Just remember, for multiplication and division, those are interchangeable. So it's not multiplication comes before division. It's just because it was a little bit easier to say it as PEMDAS for that. Same thing with addition and subtraction. Addition is not before subtraction. Those are like interchangeable. However, there is a divide between multiplication and division and addition and subtraction. Okay, so multiplication and division always come before addition and subtraction. So what that means is I'm going to multiply this 1 times 2 first. So I have a 1 minus a 3. 1 times 2 is going to be a 2. Minus 5, quantity squared, plus 1. Okay, now the only thing left to have in the parentheses is just to subtract. So let's go ahead and subtract. So I have a 1 minus 3. 2 minus 5 is going to be a negative 3. Quantity squared, plus 1. All right, so I've technically gotten rid of my parentheses. I'm keeping them there because I want to make sure you understand negative 3 squared is negative 3 times negative 3, which is now going to make a positive, okay? But there's no other operations I can do inside the parentheses to simplify it. So therefore, that's why we can just leave this off. So I have a negative 3 quantity squared, negative 3 quantity squared, negative 3 quantity squared, So that's going to be -3 times -3, which is +9. So I have a 1 minus a 3 times a 9 plus 1. Okay, and again, just remember, we're going to do the multiplication first. So -3 times 9, right? We have to multiply first before we do the subtraction or the addition. So -3 times 9 is going to be -27. So I have a 1 minus a 27 plus 1. And now the important thing is when you're doing like addition, subtraction, or multiplication, division, always go from left to right. Okay, so here I'm not going to add before I subtract, because subtraction comes first because it's left to right. Right? Remember I said they're interchangeable? They are. Right? And multiplication and division is interchangeable. Just work left to right. Addition and subtraction is interchangeable. Just work left to right. So what I have here is 1 minus 27, which is a -26 plus 1. And -26 plus 1 is going to equal a -25. And that's going to be my final answer for on that one. All right, and the last example is going to be evaluate the absolute value of an expression at x equals 0. So a couple things I want you to remember about the absolute value. When I have the absolute value of, let's say absolute value of x is equal to 2. Okay, what that means is x could equal a +2 or x could equal a -2, right? Because whenever you take the absolute value of a number, it's always going to turn it to the positive distance away from the definition of the absolute value means the absolute distance away from 0. So it could be in the positive or in the negative direction. It's just talking about the absolute distance away from 0. And again, like you can see this, right? If we were to look at like 0, like here's 0. So here's -2 and here's +2. Wouldn't you agree that both of these are a distance of 2 away from 0? That's what the absolute value represents. Now, when we're evaluating, all we're simply going to do is whenever we see an x, we're going to replace that with a 2. That's what evaluate for the expression at x equals 2 represents. So what I'll do here is I have a 4, absolute value of 1 minus parentheses 2, and then end absolute value. So whenever I'm doing evaluating, whatever I'm plugging in for, I always like to put parentheses around there. That one triggers me to remember what actually I'm replacing. Like I replaced the 2 for the x, so that reminds me of that. Always also, a lot of times like our absolute values can sometimes be confused with like a 1. So always make sure they're nice and kind of like distinguished here. So in this case, I have a 1 minus a 2, which is going to be a -1. So I have a 4 absolute value, it's 4 times an absolute value of -1. And absolute value of -1 is just going to be a +1, right? Because the distance away from 0 is just going to be 1. So it's a 4 times 1, which is equal to a 4. And again, you can see how I'm kind of working things out step by step here. But again, the other thing I want you to mention is it doesn't really matter what's outside the absolute value, right? We're only concerned about, well, it does, but I'm like, what you want to do is simplify the absolute value first, and then you can worry about whatever's happening on the outside. So for example, here, like a lot of students will see this -2 and they're like, oh, let's make this a +2. No. That's outside the absolute value. Leave it right there. So now I have a -1/2. This is going to be, we're going to plug in a 2 here. So a 2 plus 1. Now here comes a little bit of fraction. So just remember, like if I had a -1/2, right, times 2, remember you can rewrite that 2 over 1, right? Now the 2's you could like multiply straight across, like that's a -2 over 2, which is equal to a -1, right? Now sometimes you could like cross things out. I don't really like crossing things out. I think it's just easy to multiply straight across and then simplify. But again, you can see that this is going to be at a -1. So I have a -2 times, let's see, this is a -1 plus 1. Well, -1 plus 1 is going to be a 0, right? So absolute value of 0 is like, what's the distance away from 0 at 0? Well, it's just 0, right? So -2 times 0 is just going to be a 0. All right, and in this example, we have a -x² plus 1. So again, let's just plug it in. So -2 squared plus 1. Now, this problem is different than the one, if you remember, where I plugged in that -3. This one's technically saying a -1 times a 2 squared, right? So there's a really big difference here. We're not squaring a -2. We're not squaring a -2. This only thing that's being squared is the x. So when I plugged in a 2, that only the 2 is being squared. So this is going to be a -1 times a 2 squared. Well, that's going to be a 4. So that's going to be a -4 plus 1. And a -4 plus 1 is going to be a -3. And that's just going to equal a +3. If this video was helpful for you, then you're going to love the next video I have for you here.